For number 17, we're given the weekly demand function, which is here. P equals negative 0.07x plus 673. And we are also given the weekly cost function. And we are asked to find the level of production that will yield a maximum profit. So our focus here is to maximize the profit. So we need to come up with the profit function first. And of course the profit function, let's put it here, is equal to the revenue function minus the cost function. So in order to figure this out, we first need to find the revenue function. And remember that this is not the revenue function, but the revenue function is price times quantity. So this gives us the price. We're going to multiply it by the quantity. So the revenue function will be x times p. So we're going to take that demand function and multiply it by x. So the revenue function is negative 0.07x squared plus 673x. So our profit function would be that revenue function that we just formed. And then we're going to subtract off the cost function. And remember, when we subtract the cost, that the negative gets distributed into every term for that cost function. So we're going to subtract that first term. I think there's 5 zeros there. We're going to add the next term, subtract off 400x, and then subtract off 80,000. So we're going to subtract off all of those terms. So the profit function, when we combine our like terms, should look like this. Combine these two, I get negative 0.03x squared. Combine these two, I get positive 273x, and then minus 80,000. Alright, so this is the profit function. We want to find the maximum value of this profit function, and we are given that the interval that we're working with is a closed interval from 0 to 12,000. So x is limited to be between 0 and 12,000. So if we're going to maximize this, then we need to find the derivative. So we're going to use that power rule. Okay, then we're going to set this equal to 0. We're going to look for where we have horizontal tangent lines. We're going to take the derivative, set it equal to 0. And of course, this is basically, let's just put it here. Just going to set that equation equal to 0. Okay. In order to solve this equation, we're going to need to use the quadratic formula. So it will be x is equal to, and remember that this is our a, this is the b, and this is the c. So we're going to get x is equal to minus the b value, which is minus 0.06, plus or minus the square root of b squared minus 4 times a, and a is kind of long, times c, which is 273. And it's the square root of all of that, so I'm going to make sure all of that goes underneath that square root symbol. And we're going to divide that by 2 times a. Alright, we put all of that in our calculator, and I'm going to give us a little bit of a simplified form here. So underneath the square root, Once you put all that in, you square the first term and then multiply by, or then subtract 4AC from that. You should end up with 0.010152. And then we multiply those values together. We get negative 0.123, 4 zeros now after the decimal, and 12. Alright, then we're going to simplify a little bit more. I'm going to write this as equals 0.06 plus or minus this, and once we take the square root of that, you should get 0.10075713337, something like that. Just don't round yet. Leave it as exact as possible until the end. So you get that once we take the square root. So I get x equals, and we have two potential values here. We have x equals 0.06 plus that value. All of that divided by negative 0.000012. Or you also have x equals that value minus the square root of that number. So we're going to separate it with that plus and minus. And we put those values both into your calculator, and one of them gives you x is equal to negative 13,396.43. And then one gives you x is equal to positive 3,396. We're going to go ahead and round there to the nearest whole number. Of course, x, what does x represent? X represents the quantity, and the quantity goes here. The limitation was from 0 to 12,000, so we're going to ignore any negative values for that quantity because they're outside of the bounds for what we were given. And we will use this value here. Remember that this is the x value where we have that horizontal tangent line. So we're going to evaluate the profit function at the endpoints, and then also at that given value. So if I put in 0 into the profit function, you get negative 80,000. If we put in 12,000, let's see what we get for that. Let's scoot this down a little bit, actually. Okay, so let's put in 12,000. So we're putting in the endpoints and seeing what that gives. When we put in 12,000 into the original profit function, so it looks something like this. I end up getting 400,000, so $422,792.63 and some more cents. So we're going to round, basically let's round to the nearest cent. Okay, so this turns out to be the maximum profit. And we would say that that maximum profit occurs when the quantity produced and sold is 3,396 units.